Hello guys, welcome back to my channel Maison African Motives. Still working on mathematics N6. So actually we had some questions that we have been asking to work on, so that is the platform that we can have at least to actually work on those areas that you have been talking about. So actually on question number 5, working on the depth of center of the fluid pressure, you'll be asked a lot of questions there that actually are the ones that you're going to be focusing on. So if the question paper which was actually written, which is March 2019, that we are going to be using to calculate or to simplify this part of the depth of center of fluid pressure. All right, so not much guys, let's just see the question that we are given there on question number 5. How are we supposed to answer that question? So actually, if you're new, you can consider subscribing so that you become part of the family Maison African Motives. Okay, so we are given on 5.1 there. I don't know if it is much clear, or maybe I can just increase it, but that was the question there. All right, so that is a vertical plate and the shape of a trapezium is installed in a demo. The top of the plate is 10 meters wide and lies 1 meter below the water surface. All right, so yes, very, very important guys, 1 meter below the water level. Okay, the bottom of the plate is 8 meters wide and the height of the plate is 3 meters. Draw a sketch of the plate and show the representative strip that you will use to calculate the first moment area and the second moment of area about the water level. All right, so okay, let's see what you're going to have there. This is actually 5.41. all right, so we know that we need at least to show x and y. X is there because that is where we are going to have our strip there. The water, what is this one? It's a vertical plate. Okay, so it's a plate actually that we are having, and it's in form of a trapezium, guys, remember. So we've got the x and y axis there. All right, that's something like in fact I wasn't supposed to like throw like that big y. Okay, but that's the concept there. So this is your x-axis, which is actually representing the water level. All right, so in this case I use it as the water level, which means I'm going to have my diagram below. So it depends with you, maybe you want to draw it above, but the calculations of having it above, for me, I prefer using it below. That's for me guys, and it works easier for me like that. The top of the plate is 10 meters wide. Okay, that's the top, but it lies 1 meter below the water level. Remember we said our x-axis is our water level. It lies 1 meter below. So if it lies 1 meter below, we are going to have, because this is a 0 here, so -1, you're going down. So let's just say this is our -1, so it lies 1 meter below. So which means, remember, it's what can I say, we have a trapezium, and the shape of a trapezium is like this, guys. Remember I told you, let me show you here. The shape of a trapezium that you're supposed to draw is like this. This is the trapezium. The top is always bigger and the bottom is smaller, and you can also take even from the information that you are given. You will see that the top is bigger because it has got 10 meters, and the bottom we are given that the wide one is the bottom is 8 meters wide. So as you can see, it's actually smaller here. That is where it is smaller, and it's bigger on the top there. All right, so let's just show it to form a trapezium. That's a trapezium there, as you can see. That's your trapezium. All right, so you've got a trapezium there. Okay, so let's just extend this so that we can have something which is visible. I don't know if it is visible or it's doing something there. All right, but that's my trapezium. So here I marked -1. Why? Because it is 1 meter below. Okay, then let's take another information. The top plate now, take note, the top of the plate is 10 meters wide, which is this one. This is the top, which was 1 meter below, but from this point to this point it is 10 meters. Okay, remember also that this trapezium, it is divided into 2 equal parts by the y-axis. So if it is divided into 2 equal parts, this side and this side are equal, this side and this side are equal. From this point to this point to this point, they are equal. From this point to this point, and from this point to this point. That's how this works. It's going to be divided into 2. So if this is 10 meters, if you divide into 2, it means this is now 5 and this is now 5. But this is on the left, it's going to be minus 5, and this one is going to be positive 5. So if, remember guys, we need to obtain 10 in length from this point to this point, it must give you a 10, but it's divided into 3 equal parts. So that's a 5 and another 5. All right. Then you need, because remember I told you, you need to find the equation of this line. Okay. So we're going to name the points later on. You have to find this point and to find this point. Okay. Let's just leave it for now. What else do I have? The bottom. Bottom, guys, it means below. Okay, like you are wearing a bottom, which means you're wearing something that is below the top, which is a top, like a shirt, something like that. Bottom, a trouser, something like that. Okay, so bottom, that's below, top, above. Okay, so the bottom is 8 meters wide and the height of the plate is 3 meters. Okay, so the bottom is 8 meters. Remember, it's divided into 2, so 8 divided by 2, that's 4. So this one is going to be 4. And this one is going to be 4. This is on the negative side. That's why I'm writing like negative, because this is negative and this is positive. But this one, don't worry about it. Okay, don't worry about that one. All right. Then this is the plate. Here is 3 meters. That is the height of the plate now is 3 meters. So which means from this is your plate here. So from this point to this point, it is 3 meters from this point. So if it is 3 meters, guys, what is going to be this point now? Which means you're just going to subtract, because this is in the negative. So you're going to just subtract minus 1 minus 3, because it is 3 points. It is 3 meters. So we are going to subtract, because the reason why I'm doing this, okay, forget about the negative. Okay, let's forget about the negative. We have got 1 and 3 we are supposed to add, which is going to give us a 4. But since it is on the negative, it's going to give us a negative 4. That is why I was working as minus 1 minus 3, which gives us a negative 4. Now it makes sense, ne? All right. So this is negative 4, which is the lower limit, and the upper limit is minus 1. Now let's find the point, because we need to find this point. Okay, and the representative strip. Okay, is something like this. So this is that what we're going to have, which is actually in terms of y then. So I just have something like that. All right, but this is what we need there, something like that. Don't worry about this, but you just need to indicate it. Okay, but just draw a line or something like that and indicate y like that. Okay, so let's find the points, guys. These are the ones which are important. Okay, remember this point is written in terms of x and y. So our x, this is our x, which lies in the x-axis. X is what? X at this point is 5, and y, this is y-axis. The point in the y-axis is minus 1. Okay, here our x is at 4. From here to this point, it's 4 units. So your x is 4, and y at this point is minus 4. So these are the points that you're going to take, the value of x and the value of y, the value of x. Why are we determining these points actually? Why are we are going to see this later on, but the diagram, that is the diagram there, just a normal diagram. Okay, so that is what you are required to actually know. Just for 2 marks, they need you to know this, guys. So you're supposed to at least be very fluent in whatever that you represent. Okay, then what's next? On question 5.42, we are now asked to calculate the relationship between x. Calculate now. Calculate, guys, take note. Calculate the relationship between x and y, as well as the area moment of the plate about the water level, as well as the area moment. Okay, which is the first moment there. All right. What is the relationship, guys, between x and y? Remember, the relationship between x and y is now the one that is formulated from these 2 points. We are going, because this is a straight line, so you're just going to find the equation of this line. Okay, so the relationship is obtained from the straight line. So this is 5.42. So we need the relationship first. The relationship between x and y, of x and y. So you need to find the equation of what? The line. So find the equation of the line. So we are going to talk about this after finding the equation of the line, what you're going to do. Okay, so let's, for the meantime, find the equation of the line. So you've got 2 points, 5 and minus 1 and 4. So I'm just going to remember, when you want to find the equation of a line, guys, you need at least to have a gradient, and to have gradient you need the points, that's x2, y2. So m represents the gradient, because remember that the equation of a line is given in the form of y is equal to mx plus c. All right, so the relationship there, guys, we need to find the gradient, which is m, and the gradient, that's y2 minus y1 over x2 minus x1, and this is supposed to be used from your N3 mathematics there. All right, so your y2 is minus 3, minus 4, sorry, minus 4, that's y2 minus 4, y1 minus 1, so it's minus 4 minus y1, y1 is minus 1, so it's supposed to be negative there. And our x2, let's quickly rush here, our x2 is 4 and our x1 is 5, that's 4 minus 5. All right, which is going to give us a negative, actually that's 4 minus 5. All right, so if you are to simplify there properly, I don't know how you're going to do it, but you're going to obtain something like negative 3 over negative 1, which is going to give you a 3. Okay, so it's actually the, like you've determined, what can I say, like you've got the gradient there. So it depends with the line also. Let me show you. Where is that paper now? All right, this is it here. You could have used this side. Still, you're going to have the same thing, but the way the presentation is going to be like a little bit different because of the side that you're going to choose. Okay, so it's best for you to choose the right hand side, guys. Always choose the side with power, the right hand side. All right, so okay, anyways, just the right hand side. Then the left hand side, yes, you can work with it, but it's best for you to just use the right hand side, okay, so that you don't do mistakes there. All right, so that's it, guys. We have got the gradient, but we need the equation. Remember the relationship, find the equation. So the gradient now, y is equal to m, that's our gradient 3, so y is equal to 3x plus c. What is the y-intercept? We have to find this y-intercept, guys, so plus c. So how can you find the y-intercept? You just substitute from the 2 points that you had, any, where did I write these points? Okay, these points are here. From those points, just choose any of your choice here. These are the points, so I'm just going to choose this one. Y is equal to minus 1 when x is equal to 5. So in place of x, I'm going to substitute 5, and y is equal to minus 1 because I need to find the value of c. So remember, we take any point of your choice. Any point, you can use this one. Still, you're going to obtain the same equation. So y here is minus 1, x is 5. Okay, so y is minus 1 when x is equal to 5. So it's 5 by 3, no, 3 by 5, sorry. That's 3 by 5 plus c. All right, and 3 by 5, which is going to give us a 15, all right, plus c. And you can transpose this, which is going to give us something like a negative 16. Is it a negative 16 or is it what I'm obtaining here? 3 and negative 1 there. That's 5, which is 50. So it's going to give us negative 16, which is equal to c. All right, let me just cross-check there if we are having the same thing, guys. Okay, but that's it, guys. It's going to be a negative 16. Just cross-check your working also, but that's the concept here because that's your gradient. You substitute 15, then negative. Okay, so now the gradient is there, the value of c is there. Substitute into the formula, okay, which is okay, effect here because you're just going to substitute. So y is equal to 3x, c is there, and our c is negative 16, like this. All right, yes, that's what you're going to have as our final equation there. Okay, guys, it's a relationship between x and y, yes, but this relationship should be in terms of x, like you have to make like x to be the subject. Remember guys, I talked about this when you are calculating the first area moment, that this is the formula that you're going to use, that the area moment with respect to x is going to be y times 2x, which is from RDA. So this is supposed to be 2x, which means you're supposed to find it in terms of what? In terms of x. Take note about this, guys, okay? So we have to make x to be the subject here. So how can we make x the subject? Transpose. This is going to be y plus 16 is equal to 3x. Then we divide by 3, which is going to give us x. Remember, we want to make x the subject. So our x now, y plus 16 over 3, which is the same as x is equal to y over 3 plus 16 over 3. It's just one and the same thing, guys. Remember, we can separate this one over 3 plus this one over 3. So that's y over 3 plus. Okay, so that's the relationship that we have in terms of x, or you could have written it as x is equal to y plus 16 over 3. Take note, guys, all these calculations, we were just finding the relationship here. We haven't answered the other question. This was just a relationship. But the other question is asking us to calculate as well as the area moment of the plate about the water level. Okay, so the area moment, this is the first area moment that we are talking about. So now, from the diagram that we had here, remember we are talking about a representative strip, which is in terms of what? Which is in terms of a y there. So what am I going to do, guys? I have my x, which is in terms of y, and also on the formula then. Okay, let me show you here. We made our x to be in terms of y. All right. The representative strip is also in terms of y. All right. So the formula now that we are going to use for the now, okay, let me just write it aside so that I don't confuse you here. So this is the first moment actually. It's still on the same question, but we are asked to calculate two things here. So we need to calculate the first moment area. All right. So how am I going to find this? Remember, guys, I told you about this formula before, that if you take as the water level, there is area moment about x, which is going to give us something like this, and that is 2x there dy. So from RDA, so we got the area moment about x, which is going to be AB RDA. So this is the area that you're talking about, and remember, moment, it's the area times the perpendicular distance. So the perpendicular distance that we are talking about is y in this case, that is the perpendicular distance, and the dA, which is the area, is going to be 2x dy. All right, that is what we are given from that formula that I showed you there. All right, so if this is the formula, guys, as you can see, 2x means we have to substitute the value of x, or the expression that we had in terms of x. Which expression are you talking about? This expression that we had in terms of x, which is now, as you can see, it has got y here. So the moment you substitute, you are now remaining with what? With y, because this is supposed to be with the respect to y, not with respect to x. That's why we have to remove this x. All right, so what are the limits? The limits a and b are the limits of the water there from the here. This is your lower limit, your upper limit. So that's your a, and this is your b. Okay, upper limit, because -1 is bigger than -4. Remember that. All right, so we are going to have -4 -1, and y is representing just a normal variable, which is the perpendicular distance. So it's going to be y like that, remains as it is. Then 2x, that's 2 by x. What is our x, guys? What is our x? This is our x here. Remember, that's our x here, y over 3 plus 16 over 3. Or this one, you can take this one, or you can take this one, depending with what you want, guys. But for me, it's easier for me to separate like this. I'm going to find something in an easier way if I separate. Okay, so that's me, guys. I'm going to use this separated one, y over 3 plus 16 over 3. So I have substituted in place of what? In place of x, this is my x. From that relationship, remember this was your relationship, this one. So you are taking from the relationship between x and y, then you substitute now. And we are integrating with respect to y there. So as you can see, everything is under y. So you can actually find what? You can actually find the integral. But what can I do here, guys? There are so many things that I can do before I finally do my integration here. There are so many things which needs to be done there. What are things that we can do, or which part can I actually do? I can see that this 2 here, it was supposed to actually multiply this bracket, okay? These 2, it was supposed to multiply everything, but I cannot waste that time. I can just leave it like that. This 3 is common here, guys. As you can see, this 3 is common. So you can actually take it out of the bracket like this, factor it out. So if I factor it out, it now means I'm going to be left with this y alone, and I have taken out these 3 out of the bracket. So I'm going to be remaining with y plus 16. Does it make sense, guys? Or you could have just done this, guys. Okay, you could have done this 2 into this one. You multiply that's 2 times x, which is gonna 2 times y there, which is gonna be 2 over 3 y plus, you multiply again, that's 2 times this one, so it's gonna give you 2 over 3 times 16, actually, like this 2, just like what you did on y, 2 over 3 by 16. So as you can see, 2 over 3 is common, so you can actually factor it out. That is what you just did here. You have factored out 2 over 3. So this is what is going to remain. And remember, guys, when there is a number which is multiplying like this and inside an integral, this number can be taken outside of the integral. So you can take out this 2 over 3 outside. Sorry for that. Okay, so let's take this out. That is going to be 2 over 3, the integral of, we have taken out these 2 here. After taking out these 2, what is going to remain? We are going to remain with this because it's now outside of the bracket. Okay, so take note, guys, this is what is going to happen. But can we like integrate these, guys? It's impossible. Are you seeing that? So we have to expand the bracket at least. So we're going to expand y and 16. So y times y, that's y squared. We are now expanding the bracket there. So you're going to remain with y squared. Then y times 16, which is 16y. So we're going to remain with plus 16y like this. And this is with respect to y and our limits, -4 up to -1. So now we have got an easier or a simpler integral that we can do, because we are now left with y squared. So let's integrate. I think at this stage we are now familiar, much familiar with this. Y to the exponent of 2 we are going to add, which is y to the exponent of 3 over 3 plus 16y, this is 1, so it's going to give us 16y to the exponent of 2 over 2, and we've got our limits here, which is -1 and -4. All right, so these are the stages that you had, guys, and as you can see, it's now easier for us to actually simplify, because we just need to substitute, because 16 over 8, 16 over 2 is actually 8, so you can substitute the limits. That's your area moment here. With respect to x is going to be 2 over 3 into, so you can substitute the limits. When y is -1, we're going to have -1 here, -1 here. So it's going to be -1 to the exponent of 3 over 3 like that. So I'm just going to open another bracket like this. We've got plus, remember 16 over 8, guys. 16 over 2 is actually an 8 there, so you can just write it as 8, but you're substituting -1, so it's plus 8 -1 to the exponent. What was the exponent there? It was 2. All right, then you close this bracket. Take note, 8 I'm obtaining from 16 over 2. Okay, then I subtract the lower limit, which is a -1, so I'm going to subtract this now. By this time I'm just substituting -4 this time, so it's -4 to the exponent of 3 over 3 plus 8 I substitute -3, -4 this time, so it's -4 to the exponent of 2. Then I have to close this bracket. All right, so that's the stage, guys. That's what we had there, and I don't think there's nothing that we're gonna do. You just need to use your calculator there, guys. So if you use your calculator properly, you are going to obtain -66, which is the area moment, which is going to be in cubic meters. So it's a negative, and these were meters. If you take the measurements, guys, that we're working with, it was 1 meter, 10 meter, whatever meter, it was in meters. So these were not like units. That's why we have to write it as cubic meters. Okay, so that is the first area moment, which is the area times the perpendicular distance. So from the formula, first area moment, you're supposed to take the formula, the perpendicular distance times the area. So the moment you have this formula, you just need to substitute. So as you can see, if your relationship is wrong, that means everything that you're going to do here will be wrong. So make sure that the relationship between x and y is actually correct. Okay, so once at this stage, it's now easier for us to calculate. So this is our first area moment. Let's just put it aside, and let's see the next question here. The next question is now calculate the second moment of area of the plate above the water level as well. Take note, these are two things which are asked here: the second moment of area as well as the depth of center of pressure on the plate. The depth of center of pressure on the plate. All right, so what are we going to have on the second? Okay, let's just write here 4.3. which actually on the second moment of area, the only thing that changes, guys, is this. We have got the second moment of area. The only thing that is second there, you just square the perpendicular distance. That's it. That's the only thing that you changes there. So it's going to be something like this: b a r squared dA. So as you can see, second moment, you just square that r squared. Once you're done, and remember our r squared was representing y squared, so it's going to be a b y squared dA. So as you can note, if you can know the first moment of area, it's now easier for you to obtain the second, because the second is just to square this y, and this dA, remember we said it represents what? That's a b y squared, and this dA is 2x dy, like this. So the formula is now there. You have completed the formula, and the second moment of area, the one that is measured in what? That's meters to the exponent of 4. So as you can see, knowing the first area, the first moment of area, it's the one that is best, because this one you can actually formulate from the what? From the first moment of area. So anyways, let's substitute, guys, and see what we have, because already this 2x you calculated before, so it's just a matter of what? Substituting. All right, so let's have this, guys. So you're going to have -4 -1. These are still repeating as they were with our a and our b there. Does it make sense, guys? We've got a here and we've got b, upper limit. Okay, anyways, the way that we got there. So let's substitute and see what you're going to have. That's y squared dA, which is 2x. So our x, guys, remember our x, the one that we got there, and we actually wrote that x, if we are not mistaken. We actually wrote this x here, because we substituted here and said 2x, and this is what we got here. When we took this out, it was like this. So this was y plus 16. So because this is just y squared, the one that we just removed, so this is going to remain as it is, 2/3, and this y plus 16, guys. So you're not like repeating, because you did this before. So you're just going to take this 2/3, and we had y plus 16. This is what you're just going to take. All right, dy. So it means now I can just take this out, 2/3. So you're going to have 2/3, the integral of -1/4. Take note there the limits, guys, and you are left with y squared and this. So because if you take this out, you are now left with y squared. So y squared is gonna multiply the bracket. Okay, so it's y squared times y which is y to the exponent of 3. Then it's y squared times 6 there, which is 6y squared dy. Then we are done. Integrate, guys, find your answer there. You're done. 2 over 3. The integral of y there is going to be a 4. You add there, that's 4 over 4. All right, then this is a, was it a 6 or was it an, okay, anyways, let us expand. This is going to be 3 because you add there. So it's 6y to the exponent of 3 over 3. But does this make sense? All right, then we've got minus 4 and minus 1. And 6 over 3 there, that's actually a 2 here. This is going to just give us a 2. Remember, this is going to just give us a 2 there. So it means we are going to have something like 2 over 3. All right, let's see the limits. We've got minus 1 and minus 4. So minus 1 to the exponent of 4, guys, over 4. Okay, so minus 1 to the exponent of 4 over 4. Just put a bracket here. Plus 6, guys, let's just divide this. 6 divided by 3, that's a 2. So it's going to be 2 here. So we've got 2, and our y is still minus 1. But this time is to the exponent of what? To the exponent of 3, isn't it? Yes, that's to the exponent of 3, something like that. All right. Then we subtract the lower limit, which is a negative 4. So that's actually putting a negative 4 here. So that's negative 4 to the exponent of 4 over 4 plus 2 into negative 4 to the exponent of 3. Yeah, that is what you're going to have. You make sure that you close your brackets properly there. Make sure that you close those brackets properly. And let's see what you're going to have from this calculator now. The part that I'm actually worried about, guys, is on our y there. That is the part that I'm actually worried about. But anyways, that's what you're going to actually have. Does it make sense, guys? Does it actually make sense? All right. The y plus 6 there, was it the y plus 6? Because on my calculator, the part that I'm obtaining here does not make sense at all. That was y plus 16, not y plus 6. I hope someone saw this. So it means everything is now affected because this is like a 16, like a 16, like a 16 there. Jesus, that's the 16 there. All right, that's a 16, a 16. And how is going to affect this? How is it going to affect? So it's going to remain as 16 over 3. Okay, so it's going to remain here as 16 over 3. So this is going to remain as 16 over 3. This is going to remain as 16 over 3. Now it makes sense. All right. So let me see what I'm going to have if I simplify this properly, guys. You are going to have at least, because that's our limits are now being applied. So it's going to be something like a 181,5, if I'm not mistaken, the 181,5. And to say these are to the exponent of 4, like that. Meters to the exponent of what? Meters to the exponent of 4. So once you're at that stage, you have your answers properly written or properly presented. The question was a continuation. It wasn't only one thing there, but it was also to calculate the depth of center of pressure of the plate. Okay, so we need the depth there. All right, so guys, these are a lot of things. As you can see, we have got a lot of things, guys, a lot of things. Okay, so the depth of center of pressure, that is white bar like that, which is the second moment of area, second moment of area over the first moment of area. All right, that's the first moment of area there. All right, so our second moment of area was actually 181, the one that we just calculated here. That was our second moment of area. If you had to cross check, it was 181 and it is meters to the exponent of 4. So we've got 181,5 meters to the exponent of 4 over the first moment of area, which was, yes, the first moment, which was negative 66. Yes, and this is meter cubed like this. This is meters cubed and it's minus 66. All right, so this is minus 66 meter cubed like that. All right, so you use your calculator like that. All right, it's gonna give you something like, and it's a negative 2,75 meters. All right, because of the the part that we have taken, because we have taken the x-axis as the water level, so that is why it becomes a negative. But it's not a worry, guys. In exam you can actually use this a depth of center of pressure as a positive. There's no worry. But when you take it the water level, like what we use, that it's below the water level, that is why it is becoming what? It is becoming a negative. But the calculations, or the way that you're supposed to answer these questions, that is the idea there, guys, and the stages. So as you can see, guys, we've got a lot of things there that you just need to work on. So guys, just become part of the family by subscribing, so that you won't miss any other classes that we shall be having any other time from Amazon African Motives. Till we meet again.